Slide 1. Welcome. This is FFGFT, the fractal field geometric fundamental theory. Over 6 parts, I'll walk you through a single, slightly stubborn idea that the whole zoo of physical constants might come from one number and one shape. Part 1 lays the foundation. We'll talk about why physics, deep down, is about ratios, about how things compare, rather than about absolute quantities, and we'll meet the one-dimensionless parameter that the rest of the theory leans on. Let's begin. Slide 2. Everything starts here with one number. We call it Greek x. That's the Greek lowercase x letter, and it's tiny, 4 divided by 30,000, which is 1 over 7,500, roughly 1.3 times 10 to the minus 4. From Greek x we get the fractal dimension of space, written df equal to 3 minus Greek x, so just a hair under 3, about 2.999. Now, honesty up front, the form of Greek x, the 4/3, the symmetry, the way the torus winds, that's derived from geometry, not guessed. But the size of it, the 5 to the 4th hiding in that 30,000, that's an input anchored either in music theory or in the Higgs sector. The theory says so openly, it treats its own foundations as critically as it treats anyone else's. Slide 3. Here's the heart of it. Time-mass duality, T tilde times m equals 1. T tilde, that's an intrinsic internal time. The little tilde just marks it as the theory's own time variable, and m, the mass. They're locked together inversely. Heavier things carry faster internal clocks. This isn't about clocks on your lab bench, it's about how time and mass get bundled together when you wrap space up into a compact shape. Picture a 4-dimensional donut, the T4 torus, with 4 circles. One of those circles carries mass and time at the same time. Not one circle too many, not one too few. And it means E equals mc squared, and plane E equals m are saying the exact same thing once you realize c, the speed of light, is just a conversion factor between two systems of units. Slide 4. This slide is the method in a nutshell. The standard model, our best current theory, has more than 19 free parameters. Every one of them is measured and plugged in by hand, and each carries units that quietly hide a choice of convention. Ask why these values, and the honest answer is no idea. That's out of scope. FFGFT splits the job into 2 layers. Layer 1 is pure ratios, mass ratios, coupling ratios, the Koide number, all parameter free, unit free, and exactly computable. Layer 2 is the single handshake with the real world. Pick one reference, say the electron's mass in kilograms, and every ratio turns into an absolute number. The point is that the ratios are the actual physics. The absolute numbers are just ratios plus a choice of yardstick. Slide 5. Let's strip physics down in 2 steps. Step 1. The classic move physicists already make set h bar, c, g, and kb all equal to 1. That's Planck's constant, the speed of light, the gravitational constant, and Boltzmann's constant. They're all conversion factors, and setting them to 1 makes them vanish. Step 2, the bolder one, even alpha, the fine structure constant, about 1 over 137, the strength of electromagnetism, can be absorbed into how we define charge. So what's left after both steps? Just dimensionless ratios and Greek x. Everything that survived is intrinsic physics. Everything that disappeared was bookkeeping, necessary in the lab, but not a law of nature. Slide 6. A natural question. If you're juggling fractal geometry, don't you need messy correction factors everywhere? Mostly, no. In ratio land, the calculations are exact. A small fractal correction, kfrac, about 0.986, which is 1 minus 100 times Greek x, so 100 recursion levels deep, only shows up when you convert to real SI units. And compactified time here is completely static. The flow of time comes from traveling through the geometry, not from the geometry itself. Where you genuinely need the bridge constants c and h bar is when a lad measures meters, seconds, and kilograms. Fun fact, the 2019 reform of the SI system fixed c, h bar, and kb to exact values. The theory reads that, as the establishment quietly confirming these things, really are just conversion factors. Third, 7. Here's an old headache. The gravitational constant g defines the Planck length. The Planck length shows up in quantum gravity. Quantum gravity then constrains g. The definitions chase each other in a circle. FFGFT's diagnosis: that circle only exists because these are unit carrying constants. They're all conversion factors for one underlying structure, so of course they seem mutually defined. The cure is simple: state everything as ratios, which need no units at all, and the circle just dissolves. One geometric input, Greek x, and a web of derived ratios. That's the whole toolkit. The payoff, alpha and g, stop being fundamental mysteries and become derived quantities. In natural units, g equals Greek x squared over 4 times me, the electron mass. Slide 8. Let me show you the whole chain, left to right. You start with Greek x, the geometric input. From it you get g equals Greek x squared over 4 times me, gravity from Greek x, and the electron mass. From g you get the Planck length, Lp, by the standard textbook formula. Multiply that by Greek x and you get L0, the sub-Planck length, about 2 times 10 to the minus 39 meters. That's the only relation that scales as plain Greek x to the first against the Planck length. And from there, every remaining constant follows. The honest bit: every single step is either a ratio statement or an openly declared unit conversion. Nothing gets smuggled in. Slide 9. So what about Einstein's famous equation? FFGFT says E equals mc squared, and the bare E equals m are the same statement, just in 2 different unit systems. The c squared, the speed of light squared, is a conversion factor between 2 ways of measuring the same thing. The real content is just that. Energy and mass are the same. The factor is bookkeeping. And once you separate intrinsic time, t tilde, from ordinary coordinate time, even time dilation comes back out cleanly, with no paradoxes attached. Wide 10. Wide. This is my favorite analogy, and it's musical. A perfect fifth is the ratio 3 to 2, and it's the same move no matter which note you start on. Intervals are relationships, not fixed positions. Back in 739, Euler drew tones as a lattice of these ratio operations, his tonets, or tone net. That's the historical blueprint for Greek x. There's even a direct parallel. Musical commas, those tiny mismatches that pile up when you go round the circle of fifths, are exactly the kind of small fractal deviation that Greek x captures. Physics, it turns out, behaves a lot like tuning theory. The same structure that lets you transpose a melody to any key is what lets physics be independent of your choice of unit. Slide 11. Why a donut and not, say, a sphere? A few reasons. The 4 lengths of the torus follow a geometric ladder, L mu equals L0 times 2/3 to the power mu, each rung 2/3 the size of the last. That ladder builds the scale hierarchy of the model. Periodicity, the fact that paths close back on themselves, gets rid of the infinities that plague other theories. And crucially, a torus has a non-trivial loop structure. Mathematicians write pi1 is not 0, which a sphere lacks. That's what lets stable winding modes exist, and those windings are what we call particles. Honest caveat: that we live in 3 space dimensions plus 1 of time is taken as input. The periodicity, the torus topology, and the minimal design, those are the parts the theory actually derives. Why 12? Let's pull part 1 together. One dimensionless input, Greek x equals 4 over 30,000. Its structure is derived, only its magnitude is declared input. No cheating there. The core relation, T tilde times m equals 1, is a compactification relation, and it's the shared root of quantum mechanics and relativity in this framework. Physics splits into a ratio layer, which is exact, and a declared conversion layer for SI units. The famous constants h bar, c, g, kb, even alpha, all melt into conversion factors. What's left is geometry. And the methodological grandparent of all this is Euler's tone net from 1739, ratios. As operations, the very same idea, 3 centuries earlier, in music. 13. Slide 13. Quick recap before we move on. One-dimensionless input, Greek x. Structure derived and magnitude declared. T tilde times m equals 1 as the compactification relation, tying quantum mechanics and relativity together. A ratio layer that's exact, plus a declared SI conversion layer with the constants playing the role of bookkeeping. And what remains, once you clear all that away, is pure geometry, with Euler's tone net as the ancestor of the method. Next up, part 2, the Lagrangian and the field dynamics. Slide 14. Part 2. Here we go, from one field and one coupling to all the structure that the standard model needs. 19 plus parameters to describe. If part 1 was about ratios and geometry, part 2 is about writing down the actual physics, the Lagrangian, and showing how little you really need to feed in. Slide 15. Let's be fair to the standard model first, it works beautifully. But understandable? Less so. More than 19 free parameters, all fitted to experiment, none explained. 3 separate gauge sectors, each with its own coupling machinery, bolted together by hand. And 0 answers to the question, why these particular values? By construction, that's just outside its remit. Even the Higgs mechanism, brilliant as it is, adds mass without adding understanding. The mass values stay as input. FFGFT's claim is bold. The same phenomenology can be organized around one single scalar deviation field living on the torus. Slide 16. And here's that radical compression on a single line. The Lagrangian, call it script L, equals epsilon times the derivative of delta m squared. Let me unpack the symbols. Delta m is the field, it's the mass deviation. How much the mass departs from its baseline, point by point. Epsilon is the single coupling, and it's fixed by Greek x. Everything else is just the geometry of the torus. So particles aren't separate fields anymore, they're winding and knot patterns of this one deviation field. Antiparticles? No mirror copies needed, just the same pattern wound the other way. And the Higgs isn't an add-on, its job is folded into how delta m interacts with itself. The slogan, no particles, only field knots. Slide 17. Well, now, for contact with real quantum field theory, you flesh that out into 3 terms. The kinetic term, 1/2 the derivative of delta m squared, that's the field's motion. The mass term, minus 1/2 mt squared times delta m squared, where mt is the mass scale of the deviation field. And the interaction term, gt times psi bar, psi delta m, which couples the field to the fermions. Psi and psi bar are the Dirac spinors, the standard description of matter particles, and gt is the coupling strength. From this, you derive proper Feynman rules, which means quantum corrections you can actually compute, not just postulate. And the numbers loop right back to the ratio layer from part 1. Geometry and Lagrangian tell one story. Slide 18. You might ask, why keep 2 different descriptions around? Isn't that redundant? Here's the thing. The geometric form lives on the torus and speaks in windings, phases, and ratios. It's ontologically primary. It's what the theory claims is actually true about the world, and it's ideal for exact, parameter-free derivations. The field theoretic form lives in flat space-time and speaks the language of quantum field theory. It's pragmatically indispensable. It's how you connect to detectors, scattering experiments, and the existing literature. Keeping both isn't redundancy. It's the declared bridge between what is and what gets measured. What? Slide 19. A neat trick in 3 steps. Step 1. Rewrite. You reformulate the Dirac equation so the mass parameter gets replaced by ratio expressions in Greek x. Mass becomes derived, not fundamental, no free parameter. Step 2. Verify. Document 54 runs the full numerical table, checking every replaced parameter against its real measured value through the declared conversion layer. Out in the open. Step 3. Interpret. The first part of document 53 is pure parameter-free ratio physics. The second part adds the single SI reference. That separation is just the 2-layer structure from part 1 in action. Slide 20. Now, a genuinely striking result. You can write Greek x as lambda h squared times v squared over 16 pi cubed times mh squared. In words, lambda h squared is the Higgs self-coupling, v is the Higgs vacuum expectation value, the field's resting value, and mh is the Higgs mass. Plug in the measured electroweak numbers and you get about 1.3 times 10 to the minus 4, which matches Greek x. That's a completely independent check from a totally different sector, and it lands. Honesty note, an earlier version had the wrong prefactor, 64 pi to the 4th. It was corrected to 16 pi cubed and logged openly as correction. K1. This Higgs agreement is the strongest cross-sector check in the whole corpus. Slide 21. 1. Watch this chain, no free step anywhere. You start with the T0 Lagrangian. Its self-consistency condition admits exactly one dimensionless solution, so Greek x is unique, not chosen. From there, g, the gravitational constant, follows as a derived quantity. From g, you get the Planck length, and the Planck length times Greek x gives L0, the sub-Planck minimum, about 2 times 10 to the minus 39 meters, smaller than the Planck length by that factor of Greek x. One important clarification: L0 is not a black hole radius and not a distance you could ever measure. It's a structural floor built into the geometry. Slide 22. 2 documents, 2 moods. Document 129 is the simple route. It rewrites the whole dynamics at textbook level. 1 field, 1 potential, 1 coupling. The goal there is to make the compression auditable, in the spirit of, if you can't say it simply, you haven't really understood it yet. Document 67 is the mathematical spine. The updated time-mass Lagrangian foundations with the duality T tilde times m equals 1 implemented right at the level of the action. It connects the field picture back to the geometric picture, and the bridge is checked in both directions. Slide 23, part 2, in 5 lines. One deviation field, script L equals epsilon times the derivative of delta m squared, carries what the standard model spreads across 19 plus parameters. The extended form, with kinetic, mass, and Yukawa terms, gives you Feynman rules and quantum corrections. The 2 formulations, geometric and field theoretic, are both needed and explicitly bridged. Mass as a fundamental parameter gets eliminated in the Dirac sector, and the 5-step chain, Lagrangian to Greek x to g to Planck, length to L0, pins down the minimal length with no free choices. Next, part 3, particles and constants. Slide 24, part 3. This is where it gets concrete. Computing from ratios, the very quantities the standard model just takes as inputs. Lepton masses, the fine structure constant, the gravitational constant, lifetimes. Let's see how far one number can carry us. Slide 25. The 3 charged leptons, electron, muon, tau, each get 2 numbers. For the electron, an invariant Re of 4/3 and a Greek x power Pe of 3/2. For the muon, R mu of 16/5 and P mu of 1. For the tau, R tau of 25/9 and P tau of 2/3. The R's are rational invariants, straight from the torus geometry. The p's are powers of Greek x. Nothing is fitted. And the three generations are linked by that same ladder ratio. Q equals 2/3. They're not three independent things. They're harmonic overtones of one resonator. Honesty log, the tau prefactor was first 8/3, then corrected to 25/9, documented as correction K2. The Koide number comes out as 0.677, computed, not fitted. Slide 26. Alpha, about 1/137, has puzzled physicists for a century. Here, it's derived from the structure of Greek x as a verification, not a starting point. Heard, if you like, as torus harmonics. Note that H bar and C only show up as SI conversions. The dimensionless core of alpha is geometric, not a constant of nature, but a ratio statement. So alpha changes status from fundamental mystery to derived ratio, exactly the same demotion G got back in part 1. Feynman once said he'd love to know where 137 comes from. FFGFT's answer, torus geometry plus Greek x. Slide 27. Gravity gets the same treatment. In natural units, G equals Greek x squared over 4 times me, the electron mass, and then you convert to SI through the declared bridge. The strong claim here, gravity isn't a separate force with its own private constant. G measures the very same geometry that sets the electron's mass scale. And that notorious experimental scattering measurements of G, it's discussed as a problem in the conversion layer, not in the geometry. Together with alpha, the two great fundamental constants of classical physics, both reduced to Greek x plus a bit of unit bookkeeping. Slide 28. This is the full ledger, every value, every derivation. The fundamental parameters, Greek x, the characteristic T0 units, and two structural factors, each with its derivation shown. The Yukawa method, the T0 version of Yukawa couplings, giving detailed mass computations for the whole particle spectrum straight out of the ratio layer. A complete table of physical constants computed through the declared SI bridge, every value auditable. And even G-2, the anomalous magnetic moment, gets its line. It's deliberately kept subordinate, but the geometric versus semi-empirical comparison lives in the corpus. Slide 29. Two complementary jobs. Document 59 does the full count, which winding and knot classes can exist on the torus, and how they map onto the particles we actually see. The topology fixes the inventory. There's no room for arbitrary extra particles. Document 168 takes the same Greek x power ladder and stretches it up to atomic structure, so the periodic table of the elements becomes another face of the same scale recursion. And document 167 pushes one step further into real materials. It locates the properties of lithium niobate on that same ladder. Slide 30. Here's a particularly clean test. The lifetimes of the charged leptons can be expressed with the very same geometric invariants, the r's and the Greek x powers, the p's, that fix their masses. One structure, two different families of observables. These are pure ratio statements, parameter-free predictions that need no SI bridge at all, which makes them the cleanest test the framework offers. You line up measured lifetime ratios against computed invariant ratios, head-to-head, with no free parameter in between. Where the standard model needs one fitted number per particle, FFGFT offers one rational invariant per particle, all linked by Q equals 2/3. Slide 31. And now the part where the theory openly says, not yet. Both neutrino documents open with a scientific honesty preamble. The neutrino sector is the least settled corner of the particle program, and the corpus says so plainly. There's a candidate mass formula in document 47, but it's presented with its assumptions and open ends right there on the table, not dressed up as a finished derivation. In the three-layer scheme from part 1, this sits in layer 3, plausibility, not layer 1, proof. And that matters. A framework that correctly grades its own weak spots is more trustworthy than one that claims everything is settled. Slide 32. Part 3. Distilled. Lepton masses are rational invariants times powers of weak x, with the generations linked by q equals 2/3. The Koide number 0.6677 is computed rather than fitted, the old Koide riddle resolved geometrically. Alpha and g both reduce to weak x plus a, declared unit conversion. Lifetime ratios are the cleanest S class, no parameters, direct confrontation. And neutrinos are honestly placed in layer 3, where openness is a strength, not a weakness. Slide 33. Part 4. And this is the big one. Quantum field theory, Bell's theorem, Hilbert space, renormalization, even quantum computing. It's the largest block of the whole corpus, and it's where the theory really has to prove it can speak fluent quantum mechanics. Slide 34. Let me give you the lay of the land, about 25 documents, in 5 clusters. Foundations, quantum field theory and quantum mechanics, renormalization, the ultraviolet catastrophe. Non-locality, Bell, the no-go theorems, that apparent instantaneity, and the topology that explains it. Formalism, the Hilbert space translation, 4 extensions, and quantum gravity shown as a special case. Computing, a T0 compiled quantum computer, tests, Ising machines, qubits, Shor's algorithm, and more. And interpretation, to Hooft's cellular automata, Markov determinism, the core principles. That's the territory. Let's visit the highlights. Slide 35. Here's the quiet but lovely result. When you quantize the deviation field, delta m, on the compact torus, the sums over modes come out finite all by themselves. No regularization, no juggling counterterms. Standard quantum field theory has to impose an arbitrary high energy cutoff to tame its infinities. Here, that cutoff becomes the natural scale of the geometry. L0 ends the integration. Compactness does the work that regularization schemes only simulate, and the ordinary Schrödinger dynamics of quantum mechanics emerges in the low energy limit, not as an axiom you assume, but as a consequence you derive. 36. Well, now something that sounds exotic but is actually elegant. The spectral dimension, ds, basically how many dimensions a tiny random Walker feels, flows from about 2 at small scales up to about 4 at large scales. And when that happens, gravity becomes renormalizable in the ultraviolet, the high energy regime. This isn't an extra assumption. It falls out of the time-mass duality and the fractal dimension df equals 3 minus Greek x. Other serious approaches, asymptotic safety, causal dynamical triangulations, Horava gravity, all show a similar flow. The difference is that FFGFT derives it instead of postulating it. And where the dimension flows, the old classical infinities soften, which points at the geometric way out of the black hole paradox. Slide 37. Let's talk about the elephant in the room, Bell's theorem. FFGFT does not try to wriggle out of it. Bell's theorem is mathematically airtight, no hidden flaw claimed. The loophole-free experiments are real and their statistics are reproduced exactly. Kochen-Specker, which rules out assigning fixed values, independent of context, accepted too. So where's the exit? It's one specific assumption, measurement independence. On a compact torus, the settings of your apparatus and the source actually share topological structure, so the premise that they're statistically independent need not hold. That's a declared structural exit, not a conspiracy theory. The correlations are carried by the geometry, and the predictions stay identical. Slide 38. So why does entanglement seem to act faster than light? Picture 2 particles, A and B, as parts of one closed structure, with no signal path between them. What looks like instant action at a distance is really you reading out a global constraint of the compact geometry, but reading it locally at each end. Nothing actually travels at the moment of measurement. The correlation was already woven into the winding structure when the pair was born. No information is transferred, you're just resolving a shared structure. Relativistic locality is preserved at the level of the dynamics. Only a description that ignores the topology manufactures the paradox. And this, honestly, was the founding motivation of the whole project: instantaneity as an artifact of description, not a real physical phenomenon. Slide 39. Now, can FFGFT and ordinary quantum mechanics actually talk to each other? Completely. There's a full dictionary. States, operators, every quantum gate, the torus coordinates, written z, r, and theta, translate into the usual Hilbert space amplitudes, alpha and beta. Tensor products, entanglement, Bell and GHZ states, all fully translatable. Measurement gives statistical predictions identical to the Born rule. Time evolution is Schrödinger's equation in the low energy limit. So what's the bonus? The plain Hilbert space picture has the tools, but no values. It can't tell you Greek X. The fermion mass is alpha. FFGFT delivers both the tools and the values. It explains why the formalism works, not just that it works. And the translation is bijective, lossless in both directions. 40. Might 40. Beyond the standard picture, 4 genuinely new features. 1. A deformed version of the spin algebra SU2. It picks up a Greek X deformation, with ordinary SU2 as the limit when Greek X goes to 0. Tiny corrections at high energy, identical physics at low energy. 2. A new discrete quantum number, born from the torus's periodicity, with no counterpart in standard quantum mechanics. 3. A fractal mode structure. The mode functions carry the fractal dimension. df equals 3, minus Greek X, so the spectral dimension shifts with scale. No flat. Hilbert space can reproduce that exactly. And 4. Topological phases. Winding modes generate phase factors with no analog in ordinary quantum mechanics, potentially measurable with precision interferometry. Slide 41. And finally, hardware. In a T0 compiled quantum circuit, the gates are derived from the torus mode structure, not from abstract unitary matrices, but from the underlying geometry. Now, the theory predicts a tiny deviation in the Bell test value, delta C, Hs, h of order Greek X, about 10 to the minus 4, which sits below today's quantum computer noise. Not yet measurable, but testable in principle. That's a real prediction, not a trick. For context, in May 2026, IBM's Heron R2 chip measured a Bell value of 2.74, about 97% of the maximum quantum bound. That's not the T0 signature, but it shows the circuits run and the hardware works. And the implementation factored numbers up to 143 with a 100% success rate. The geometry to gate connection is established for the first time. Slide 42. And now the framework meets real machines. 3 threads. First, Ising machines, documents 161 and 162. Coherent Ising machines read naturally as native optimizers in the T0 picture and relay the quantum mechanical optimization strategy side by side with the coherent Ising machine 1. Second, qubit anatomy, documents 173 to 175, quantum dots, spin qubit control, and the question of what actually lives between the 0 state and the 1 state, read through the state spaces of the torus. Third, Shor's algorithm with photons, document 176, running Shor without a conventional qubit register on a photonic platform. None of this is offered as proof that the hardware confirms the theory. The point is narrower and fairer. The framework already speaks the language of the machines people are building, and the dialogue is written down, document by document. Slide 43. Well, where does this sit among other interpretations? 2 neighbours are worth naming precisely. The cellular automaton interpretation shares the spirit, a deterministic substrate underneath quantum mechanics. But the substrate is different. It uses a discrete cellular automaton lattice. Ours is the continuous fractal torus. The dialogue is documented and the difference is kept sharp, not blurred. And quantum gravity turns out to be a subset. Its graph dynamics embed inside the mode structure of the torus, so it sits cleanly within the framework rather than competing with it. The habit here is the same one as everywhere else. Locate the neighbor exactly, say what is shared and what is not, and keep the comparison honest. Slide 44. Part 4. The short version. Field quantization on the torus gives finite mode sums for free, thanks to compactness, no regularization juggling. The dimension flow, 2 up to 4 from small to large scales, follows necessarily from the duality and from df equals 3 minus Greek x. On Bell, it's a topological exit, not a contradiction. Predictions identical, explanation geometric. There's a complete lossless translation between FFGFT and standard quantum mechanics, and the T0 compiled quantum computer gives a real prediction delta C HSH of order Greek x, while today's IBM hardware confirms the whole thing actually runs. Next, part 5. Bridges, methodology, and validation. Slide 45. Part 5. This is where the theory turns the microscope on itself. How does it keep itself honest? What happens when you run hard numerical stress tests? And crucially, what would it take to prove it wrong? Let's look. Slide 46. The whole corpus is organized into 3 honesty layers. Layer 1, the core derivations, things proved straight from Greek x, the lepton structure, the Koide number, the alpha relation, the 2/3 ladder. Fully recomputable. If something breaks here, the theory breaks. Layer 2, the bridges, connections to outside frameworks, proved algebraically, rigorous, but with no claim to being ontologically primary. Layer 3, the sketches, plausibility explorations, consciousness, DNA parallels, cosmological analogies, clearly labeled as sketches, never as proofs, and nothing in layers 1 and 2 leans on layer 3. Negative results count as legitimate outcomes. Anyone who only ever publishes their wins hasn't understood the method. Slide 47. A piece of exact algebra. There's a matrix A Greek x with a beautiful property. A Greek x cubed equals 1 minus Greek x times the identity matrix. Its determinant is exactly 1 minus Greek x, and the fractal dimension df equals 3 minus Greek x shows up as a linear spectral dimension. Exactly proved. That's layer 2. 6 external bridges were tested against other researchers' framework. And here's a model negative result. Lobbed honestly, one bridge gave a frequency, nu-m, of 8.23 terahertz, but that turned out to be a thermal vacuum scale, around 395 Kelvin, not a quantum gravity signal. A separation of regimes, not a contradiction. A numerology filter even threw out the framework's own tempting dark energy fit as statistical noise. Dimensional change here follows 3 operation types, call them type 1, 2, and 3, which together dissolve a whole family of fake paradoxes about whether information gets lost. Slide 48. When a dimension changes in this framework, it does so in one of exactly 3 ways, and keeping them apart matters. Type 1 is duality unrolling, mass and time trading places through t tilde times m equals 1. That move is information preserving in its mode content. Time is simply the price of embedding. Type 2 is spatial projection, forgetting a space direction. That one is strictly lossy. Information is demonstrably destroyed, and we say so plainly. Type 3 is the Hilbert representation, the 4 torus and Hilbert space mapped onto each other, bijectively, a lossless translation in both directions. One label per operation, and never mixing a lossy projection up with a lossless duality. That discipline is what keeps the dimensional bookkeeping auditable. Slide 49. A subtle trap, and the guard against it. Symbolic terms combine freely on paper, but physical results don't, so naive shuffling of symbols can manufacture fake derivations. Document 1922 draws the precise line which algebraic combinations of Greek X expressions stay physically meaningful. Document 193 identifies the prefactors as genuine geometric invariants. You can't absorb or reshuffle them without changing the claim. Together, they form the backbone of what's called the Greek x to the n triviality guard, the warning that an exponent all by itself is not a prediction. The corpus formalizes the ways its own results could be abused before any critic has to point them out. FFGFT. This is the part I'm proudest to show you, the correction register. Corrections K1 through K4, points P1 through P38, and nothing ever silently overwritten. A few examples. P20, the exponent 41 quarters in a cosmological relation, is declared as external calibration, a unit choice, not a derivation. P33, the 5 to the 4th, inside Greek x, is harmonically motivated or empirically anchored. The structure is derived, the magnitude is input. P35, the warning that any quantity can be dressed up as Greek x to some power. So a measured scale hiding in an exponent isn't yet a prediction. And K4, 3 implementation bugs in version 3 of a script, duplicate points, a seed bug, a detector bias, all fixed in version 4, all affected results retracted. That one carries the first external audit entry by P. Stoyshev, dated the 11th of June 2026. Slide 51. Here's a recent intriguing find and a textbook case of the theory disciplining itself. Take a damping recursion. Each step, R, is multiplied by 1 minus Greek x, starting from R0 equal to df over 3. Ask when it passes the golden ratio's reciprocal, and you get a step number, k star, of about 3609. At that step, R equals 0.61799, which is astonishingly close to 1 over phi, phi being the golden ratio, at 0.61803. The error is just 4 times 10 to the minus 5, tempting to call it deep. But, and this is the point, 1 over phi is a passage point, not a fixed point. The only true fixed point is 0. And the same construction works for any target. So by the P35 guard, 3609 without a free parameter, holds for every target equally. So the corpus correctly downgrades it from theorem to observation. It would only gain physical content if k star were fixed independently. For now, that's open. Slide 52. And now, an honest stress test. Same machinery for every model, a nearest neighbor pipeline, 2000 points, 3 random seeds, measuring the spread and the spectral gaps, the same diagnostic Marcel Kruger used in his Run-E. FFGFT's 4-dimensional torus scores 1.33 plus or minus 0.025 inside the null band that runs from 0.69 to 2.4. 1. The rival HLV-G lattice scores 0.71, also inside its null band. The verdict? No separation. Both models land inside the null band. That actually reinforces Kruger's cautious Run-E finding, now from an independent pipeline, and it shows this particular diagnostic, at 2000 points, simply isn't sharp enough yet to single out a physical signature. We reported straight. Slide 53. A theory you can't kill isn't science, so let's name the kill condition. FFGFT would be refuted by a lepton mass ratio drifting outside the rational invariant structure, a confirmed violation of the 2/3 ladder across sectors, Bell statistics deviating from the topologically carried correlations, or a Casimir force at sub-Planck distances landing outside the T0 prediction. On the philosophy, the 4-dimensional description is fractal, open and recursive. Completeness is not claimed, auditability is. As one document puts it, what cannot be visualized is not therefore unintelligible. Structure and consequence outrank imagination, and the correction register isn't a flaw, it's a feature. Every recorded error is an error that can't be repeated. 54. Part 5. Summed up. A 3-layer method, proved, bridged, sketched, with every level clearly labeled. The triangle matrix reduction, exact algebra, 6 bridges, 1 honest negative result. The correction register, document 190, corrections K1 to K4, points P1 to P38, nothing hidden, and the first external audit. The Greek X to phi result, a passage point, not a fixed point, with the P35 guard applied to the theory's own finding, and passed. And the spectral test, no separation at 2000 points, confirming Kruger's run E from an independent pipeline. Next, the final part, dialogue, applications, and outlook. Slide 55. Part 6. The home stretch. How FFGFT talks to other frameworks, where it might touch real engineering, and the sectors it deliberately keeps in a subordinate role. Less proving, more positioning and looking ahead. Slide 56. This is a comparison series, not a sales pitch. 3 examples. With Marcel Kruger's HLVG lattice, there's a shared diagnostic channel, the gap hierarchy, an independent reproduction of his cautious runny result, and the golden ratio, as limit posed openly as a bridge question. With Stefan Vossen's dot theory, the operational vocabulary was applied carefully in document 274, and the line between declaring something and enacting it was clarified. And with Guevara's RAPMT framework, structural convergence in the layer 1 hierarchy is documented, a category error in the original version is corrected, and the comparison runs both ways. Honest dialogue in writing. Slide 57. Document 274 is deliberately a map, not a leaderboard. It charts the frameworks in the Information Physics Institute along 2 axes, what each one takes as its substrate, what it's built on, and what it takes as primitive, what it treats as given. FFGFT's coordinates, a continuous fractal torus as substrate, and the single dimensionless ratio, Greek X, as primitive, distinct from the lattices, graphs, and information primitives others use. The map is governance. Aware, it borrows .theory's vocabulary properly, with declared leftovers rather than smuggled assumptions. The upshot is that FFGFT sits in a corner no other framework occupies, a geometric substrate with one dimensionless primitive. Not a judgment, just a position. Slide 58. Where might this touch real devices? Photonics. Documents 83 to 85 use the Chinese photonic quantum chip as a catalyst, arguing for wafer integration from a communications engineering standpoint, which happens to be the author's home discipline. Document 187 turns the framework's photon sector toward actual devices, pointing at concrete experiments in integrated optics where the torus mode structure should show up. And document 167 places the material properties of lithium niobate on the Greek X power ladder, linking lattice constants to the fundamental scale hierarchy. Theory, reaching toward the workbench. Slide 59. And here the music returns, full circle. The Pythagorean comma, that small mismatch you hit when 12 perfect fifths don't quite equal 7 octaves, is the musical twin of the fractal deviation Greek X. Document 42 reads the particle spectrum as harmonic structure, overturn logic, and not just as a metaphor. Document 137 stages the fine structure number 137 as a spiral of intervals, that centuries-old riddle, reheard as torus harmonics. The tone net lineage we opened with in part 1 closes its loop right here. The same music that motivated Greek X also illustrates its consequences. Slide 60. Cosmology is kept deliberately subordinate and graded honestly. What carries forward the series of acoustic peaks in the cosmic microwave background follows Ln equals A times n over 1 plus b over n, where B equals 1/3 comes purely from there being 4 dimensions, that's genuine forward content. The recombination redshift, Z star, comes out around 875, not the 11 and 3 of standard cosmology. And the circularity of both comparisons is made explicit and symmetric. What stays input, the specific peak positions, are recognized and declared as retrodiction. No cheating. The Hubble constant via Greek x to the 41/4 is declared calibration, not derivation. And honestly, the standard measurements can't yet distinguish metric expansion from fractal time unfolding. Slide 61. Every framework earns the right to speculate by labeling it speculation. The label is part of the method. So, behind a clear fence, consciousness and biology, cortex, DNA, and related essays, explicitly layer 3 material, plausibility explorations, never load-bearing. Black holes and information, a geometric theorem that forces resonant information concentration under a shrinking area with 3 open proof gaps named right in the text, the arrow of time, and the question of the universe as a whole, conceptual essays that consume the framework rather than support it. The key point: nothing in parts 1 through 5 depends on anything in this annex. The dividing line is the method itself. Slide 62. If you want to check any of this yourself, you can. About 184 standalone documents in German and English in A4 format. A gapless correction register, points P1 through P38, each with a dated status, and 100% Python re-implementation of the core computations. Everything's on GitHub, all sources, all versions, all corrections, public. Every release has a Zenodo DOI, so it's citable and permanently archived. There's an interactive parameter explorer on Hugging Face, so you can test the core computations right in your browser. And the books are on Amazon, 5 volumes, 3 formats, in both languages. Slide 63. So to land the plane, 1 parameter, Greek x, 1 geometry, the torus, and auditable consequences all the way down. We traveled through 6 parts: foundations and units, the Lagrangian and the fields, particles and constants, the quantum sector, methodology and validation, and finally dialogue and outlook. Whether you end up convinced or skeptical, the invitation is the same. It's all open, all versioned, all checkable. Go and check it. Thank you for watching.